this video, we'll start with this example. I want to integrate this rational function. I'm given some help here in part A. I actually already have the way it splits into these simple blocks that we talked about last video. I just need to show that these are right. So I need to prove that these two sides are equal. Then once I have that, I'll use it to evaluate this integral. Instead of evaluating the integral of this, I'll look at these three smaller parts that are going to be much easier to integrate. All right, let's start. I want to prove that these two things are equal. I'm going to start with this and join them under the same denominator, over the same denominator. So I have minus 1 over x plus minus 2 over x squared plus 3 over x minus 1. So I want to know what the common denominator will be. I'm going to need some x's, and I'm going to need some x minus 1. To figure out how many x's I need to look at all the powers of x in all the denominator, and I take the biggest one. So in this case, I have x to the 1. I have x to the 1, and I have x squared. The 2 is the biggest, so I'm going to take x squared here. And that's because it's the biggest power of x that I have over here. Now for x minus 1, it's simpler. I only have one power right here, so I'm going to take that 1 as the power. So that's going to be my common denominator. Always each factor that you see in the denominators, and you take them to the highest power you see. Notice that this is not quite the product. If I took the product, I'll end up with x cubed. And that's a common denominator, but it's not the smallest one. And if you take x cubed, you'll end up having more work, and you'll complicate your life. So in this case, it's important to take the smallest one. All right, x squared, x minus 1. So if I start again, I want to put them to this denominator. In that case, I'm missing an x and an x minus 1. Now, I don't want to change my function. So if I multiply the denominator by x and x minus 1, I'm going to do the same to the numerator. So I'm really multiplying by 1, just a very fancy one. In this case, I have the x squared. I'm missing x minus 1. So I'm going to multiply the second term by x minus 1 over x minus 1. That's going to get it to the right denominator. This one, I'm missing x squared. So now all of these fractions are over this common denominator, so I can write them as a single one. I'm going to get minus x minus 1, minus 2x minus 1, plus 3x squared. Let me distribute and expand so everything cancels and I end up with a simple polynomial. I'll get minus x squared plus x minus 2x plus 2 plus 3x squared. x squared plus x minus 2x plus 2, yeah. The x squared, I'll have 2x squared left, minus x plus 2, and let me just double check whether, yeah. And then I multiply this as well, I'll get x cubed minus x squared. That's exactly what we had. All right, so using common denominators, we see that this sum of three fractions, three rational function, is the same as this big one. So in part B, we're asked to integrate this. Well, I have a choice. I can integrate this complicated one, or I can integrate this sum of three simple one. I'm going to choose this one. So instead of evaluating this, I'll evaluate this integral right here. And so I'll get minus ln of absolute value x. This one is x to the minus 2. And for this one, I'll use the same substitution I used in the first integral we saw. I'll use u equals x minus 1. Du will be dx. And I'll get 3, the integral of 1 over u du. That's just going to be a power rule, x to the minus 2 plus 1 over minus 2 plus 1 plus 3 log of absolute value of u. And I just need to replace the u by x minus 1. And that's what I get. I want you to have 3 lessons that stick in your mind from this. Here are the lessons. The first one is that partial fraction is some sort of opposite operation or inverse operation of common denominator, right? So instead of starting with different blocks that we try to put together, we start with a big thing that we try to split up. So that means that the way you'll do it will depend on how your denominator factors. That's going to determine the different types of blocks. So the types of blocks in the decomposition depend on the factoring of the denominator. The third lesson is more of a trick or a formula or something that we've done a few times, and there's a point where you don't want to do the substitution every time. After doing partial fractions, you'll often end up with the integral that looks like this. A constant over x minus a, and there's no constant in front of x. It's 1x in some way, minus a. If you have this integral, then you should take a substitution for x minus a, and what you'll end up with and we've done this twice already, is a log of x minus a plus c. Alright? So because we've done it a few times, and because this integral will appear again and again and again, I'll just let you use this as a formula. Alright, so that means that you don't need to do the substitution every single time. As long as you have 1x minus a as your denominator, this will work as is. If you have a constant like 2x plus 3, then the fact that you have a 2 means you have to take the substitution. It will affect the answer. In the next video, we'll look at one type of factors. We'll look at linear factors and linear factors that are not repeated, and we'll see how to handle them in partial fractions.